Stack and queue, both data structures are used in many applications like problem solving in operating systems, problem solving in compiler design, and many more. Let us first talk about the stack. Stack is a data structure as a linear data structure. Linear data structure is an organization of data for efficient execution of programs. Okay, that is the data structure. That is the definition of the data structure. Now, data structure, for example, suppose that we have 5 memory variables to be defined in order to solve a problem. What we do normally, we define, say it is of integer type, we define a1, a2, a3, a4, a5, right? You simply understand this concept. And when it executes, when this code is executed, this is the main memory, and elements will be scattered in the main memory. Suppose that this is a1, a5, so these are 5 elements. And suppose here the address of this a1 is 100, address of a2 is 400, address of a5 is say 900, for example. These are the addresses assigned to these variables. And when these variables are scattered over the network, we have only 5 elements. That's not a big issue. But however, whenever we do some, say suppose I want to read data to these variables, so in that case, what I will do, I will write a statement scanf %d ampersand of a1. Similarly, I have to also write the same statement scanf percentage of d a2. That way I'll have to write down 5 different statements scanf percentage d ampersand of a5. So these are 5 statements written, and we can see that there is no common link among all the variables, and this is only the way out to read 5 different statements to read these elements. However, if I change this definition, or if I change the declaration of variables into another format, like say I give a common name to all these variables, and I say that here we will have 5 elements, and all other things like data type is same as the previous one. That means I am replacing this statement with this statement. So in that case, what will happen in the main memory, instead of scattering all the variables over the main memory, it will continuously allocate the spaces for 5 variables, 1, 2, 3, 4, and 5. So this is the first element. And what I can do more, instead of writing 5 different statements to read the data, I can write a single statement scanf percentage d. See, everything is same, and here I will write ampersand of the common name and then one index, and above this I will write one statement I equals to 0, I is less than 5, I plus plus, right? So this is, here I am declaring all the variables. If I do these variables, 2 things happen. One is the variables are scattered over the space, over the main memory, and here if I do the same thing using an array, then this is actually, it allocates the space continuously, and also it gives a common name, and if I know the address of the first element, I can address all other elements. But we cannot do the same thing here we cannot, if I know the address of the first one, or if I know address of the identity of the first element or first variable, there is no way out to find out other elements in the memory. But here that problem is solved by allowing all the variables to be declared with a common name, and that concept is known as array. Again, most of the time there are many problems which cannot be directly or efficiently solved with array. So that is why we need to do some extra modifications to the existing data structure so that that can be used to solve problems efficiently. Or stack is one such special extension of array. We have, first of all, stack is an array. If I say 20, then A is an array. Now this A can be considered as a stack. If we put a restriction, first restriction is that we cannot add element in any of the place that I wish to add. Suppose in case of array, this is an array A, I am allowed to add, this is 0, this is 1, this is 2, this is 3, this is 4, this is 5, 6, and that way it will go on. And now in this array, I am allowed to add any element, say A5, I want to add element A5. A5 is this one, I will put 7. I am not putting anything in this location, that is allowed in array. But if I suppose that I am putting one restriction in this array, that I can add element in A only one at a time, Second one, the available free location to be used to store the new item, store the new element, right? So I am putting these two restrictions. Apart from that, I am also putting one more restriction. I cannot delete element from any location that I wish to. However, what I need to do, I can delete only an element which is the last element of the array. For example, here this is the first element, second element, third element, fourth element, and if I want to delete element, if these are the elements at 2, 3, 4, 5, these are the elements, then if I want to delete an element, there is a restriction in the array that I can delete only this, not this. If I want to delete this one, then first I have to delete this element, then I have to delete this element. So this is said that in the array of integers, we are putting some restrictions. The restrictions are only one element can be added at a time, only one element can be deleted at a time, and number 2, we can add the element in the available slot, which is the last available slot in the array or location in the array. Also, we can delete the last element which is stored in the array. So in that case, what we need to do, while adding elements, we must have to see how many elements are there. Suppose that this is the array and initially there are no elements stored. So this is the name of the array A, this is slot 1, this is slot 2, this is slot 3, this is slot 4, that way, and I can see that there is no element in the list. So if I want to add elements, say if I want to add 4, then this element will go here. And then again, if I want to add another element 5, then this 5 will go here. Now the question is, if I want to do that, then at any moment of time, I should be aware how many elements are there in the array. So if this is the case, then every time I have to maintain one element, that element will tell the location where I can store data. Initially this value will be 0. Once I add this 4, this n will be incremented by 1, which is equals to now 1. Next time I will add this element in 1, so it will be incremented by once again. Now it is 2. Next time, if I now suppose I want to add 6, then I will see what is the value. This is 2, so I will put this 6 here, right? That way I will go on, and if we do this, then every time I will be adding the element at the end of the array only, nowhere else. Similarly, when I will delete, suppose that I want to delete an element, say delete. If I want to delete an element, what I will do, first of all, I will see what is the value of n. Now, value of n at this point of time is 2, right? 2. But however, when I add this one, when I add this 6, this becomes 3. 3 means now this is the location which is pointing by the n, the variable n. And this n, we do not have any element there, but that is why what I will do, if I perform this delete operation, then it will delete the element from the array where n minus 1, that means 2, this element will be deleted. And once I do that, earlier n was here, now n should move here. That is why n should be reinitialized to n minus 1, and now this n will give a value 3 minus 1, it is 2. And if I want to now add element, then say element 10, then it will put it in this location which is equals to 2, and this location new element will come here. So if these restrictions are placed over a array, then that array is a special type of array, and that special array is called a stack. We will demonstrate the implementation of stack using array, right? In the programming part, first we will see a program to manipulate the content of an array. Then later on, that program that we have, the program that we write for the array manipulation, we will convert it to the programs for stack. The various operations like push, pop will be explained initially by demonstrating and explaining it with the help of normal array, and later that array will put some restriction in the operation of the array. In turn, those programs will be converted into push and pop functions. Then we will realize how a general array can be converted into a stack. The question is, write a program to perform the following operations on an array of integers, and all the operations to be performed with the help of subprograms. The first one, we need to write a function that read elements which take one parameter of the type integer, and this function is used for inserting elements into the array, where n is the number of elements to be inserted. The second function we need to write is print element. It also takes one parameter of the type integer, and this function is used for printing elements of the array. Third function is add elements, which will add element provided by x in the position POS, and n is the total number of existing element in the array. And the last one is delete element, where it will take the position from where the element to be deleted. Also the n will state the total number of elements in the array, existing element in the array. So here I have declared one variable. That variable is nothing but array of integers. I have declared one array of integers that can hold maximum 20 elements. 20 elements. Then as it is defined in the program, as it is defined in the problem statement, I have taken one read elements function, print element function, add element, and delete element. So these are the functions, and this add element function takes 3 parameters as stated earlier, and it does not return any value. So that's why all the functions I am using as a void, and del element is also, these are the prototypes of various functions. Now let me go to the definition of these functions. Here I am defining read element, and read element will take n as a parameter. It will carry the parameter n. N indicates the number of elements to be inserted. Number of elements to be inserted n. So what I am doing inside this function, I'm writing a for loop, very simple for loop, where I'm repeating the scanf statement for n number of times. If it happens, suppose that here I'm calling this function with n, this read element, the first one, line number 20, read element 4. Read element 4 indicates that we will be calling this function with n equals to 4. So this is, say, n, this is n, and we'll have 4 initially, and it will execute the for loop from line number 27, line number 27 and line number 28. So initially the value of I will be 0, and with 0, which is less than n, 0 less than n means 0 less than 4, it will execute the statement, and it will read the value from the keyboard, and it will store it in, this is the array, this is globally defined, and that array comprises of actually 20 elements starting from 0 till 19. However, at this point of time we are not entering all elements. We'll be using only 4 elements into the array. So scanf %d ampersand of ai, that will give you ai means I equals to 0, so it will read the element to location 0. Let us suppose I have type 4, it will be stored in 4, 0, a0, this is the name of the array, and this location is a0, and then 0 will be incremented to 1, I++. Then next scanf will save the data from the keyboard in second location, 1, 2, 3, 4, 5. That way it will go on, and then it will be incrementing the value of I to 2. Again 2 is less than 4, so it will put the data in this place, say 7. Then it will be incremented to 3. 3 is also less than 4, so it will put data in location 3. Let us suppose that we have entered 8. Then it will be increment to 4, but at this point of time 4 is less than 4 is not true, that means it is false. So if it is false, then it will exit this function. Then it will go here, it will return to this main program. From here the control will return to this statement. Then it will go to the print element function. In the print element function, what I am doing in the print element function, I will now go down, and what I am doing in the print element function, here print element function, the same thing will happen. Print element function, it will also take the number of elements as argument. The same thing will be repeated. If I come here in the print element, I am giving printf statement, and same way it will take n is equals to, this is being communicated here, 4, n is equals to 4, n is equals to 4 again while calling the print elements function. So it will print all the elements from 4, 6, 7 and 8. 4, 6, 7 and 8 will be printed out. Then I'm coming back to the add element function. So add element is a function, that add element function, what this add element function will do, it will add elements to the array. But while adding the element, while I'm calling this function, I'm sending basically 3 parameters. The first parameter is the x, I mean the element to be inserted. Suppose that I wanted to insert 7, then I wanted this is denoted by x, and second element, second data I'm passing to the function is pos, which gives you the position where I want to insert element. Suppose that I have given here, while calling this, I am giving this value as I'm giving this value as add element. This is 3 and 4, and I'm sending this POS position. I want to add element in the position 3, right? I want to add element in position 3, and last one it sends to the function is the number of elements in the array, and this is equals to 4. So these are the parameters that is communicated to add elements, add element function. So in the add element function, it comprises of line number, it is starting from line number 38 till line number 40. 38, 39, 40, these three statements are there, and this statement line number 30 is within the for loop. So what it will do, let me try executing this. It is taking one temporary variable I. It is taking one temporary variable I, which is defined by this statement I, and which is equals to n minus 1. N is 4, so that's why this value is 3. Then it will consider I greater than POS. POS is 3. I greater than equals to POS minus 1. So POS minus 1, which is equals to 2. And it will test if 3 is greater than or equals to 2 or not. If this is 2, this is true, then what it will do, AI plus 1. AI plus 1 means AI plus 1, I value is 3, A4 will be equals to A3. That means the data located in A3 will be shifted to A4. So 3 in 3 we have 8, that will be shifted to 4. Here it will go here. After that it will decrement the value of I by 1. If it decrements the value of I by 1, that it becomes 2, and 2 is equals to true, 2, that is also true, so it will repeat the loop once again. In that case, now it will do I is equals to 2, 2 plus 1 is 3, which will be equals to A of 2. That means this value 7 will be shifted to this place, that is it becomes now 7. After that it is now it will now decrement the value of I once again. Now it becomes 1, and it will try to execute the loop, but however 1 greater than equals to 2, it evaluates false. If it is false, then it will come out of this loop, and once it comes out of the loop, then it will execute the line number 40. The line number 40 says that A POS minus 1, POS minus 1, we can see here POS is equals to 3, that's why POS minus 1 will be equals to 3 minus 1 is equals to 2, which is equals to X. What value I am sending by in X I am sending 7, so it will put here 7. That means A2 is this position. It was previously as the same, but this old value will be replaced by this new 7. Now these are the elements in the array. So 4, 6, 7, 7, 8, these are the elements which are inserted in the array, and that will increment the number of elements. Earlier the elements were up to only 3, position 3, but now the elements are up to 4. Earlier it was 4 elements, now it is 4 plus 1 newly inserted is equals to element. Total element are 5, elements are 5. Then after that it is again the delete function, delete element function. This delete element function, what it will do, it will actually retrieve an element, and the delete element function also sends 2 parameters. One is the position from where we want to delete the element, POS, and all the number of elements, total number of elements in the array. Number of elements, it is 4, communicated as POS. Maybe you can send any 2 or 3 or anything that you want to send, and that will be considered as the element to be deleted. If I say 2, that means 2 means second element means 2 minus 1, this element I want to delete. If I want to delete this element, certainly all the elements to be shifted from here to here. As it is in addition of element, we are shifting towards n, but now in this case we are shifting towards the beginning of the array. So the same thing will be done here. That's why this I minus 1 equal to AI. So higher value will be coming to the lower value. That way it will complete the operation, and this function will delete the element. Let me execute this code and let's see what happened here. I am giving two read element statement, one read element statement. Read element statement means I'm telling that enter four elements here. Read element, it will call read element, it will go here and it will scan four elements that we have seen. After that, I wanted to see the print, I want to see all the elements, all elements that exist in the array. After that, I am adding one element. After adding element, I wanted to see the position of the array, print array, like this. So let me execute. First it will enter four elements, after that it will enter 6 in position 3, and after that it will print 5 elements, because after inserting 6, total number of elements become 5. So let me execute this code and see what happened here. Insert 4 elements, 1 2 3 4, press enter. So here I have inserted 6 in position 3, inserted 6 in position 3, so this 6 is added in position 3, and 3 and 4 are shifted towards the end of the array. So this program is working fine, there is no problem at all. Now let us see another variation of the same program. So this is the same program, this is the same problem. Write a program to perform following operations on an array of integers using subprograms, but we put certain restrictions to the problem. The restrictions are, first of all, I don't want to use this read elements, I want to remove this function. Okay, that means there is no group elements to be inserted in the array. Second one, I will print the element, but this time I will not pass any number of elements. I mean, how many number of elements I will not tell explicitly to the print element program or print element function. Then I will add element. I have the function add element. However, this time we will send only the element to be added. So finally, this delete element function will be there, and after deleting, what I am giving the restriction that after deleting the element, that element need to be forwarded to the main function from where it was called, right? So in order to do that, what I need to change, a few things I need to change. First of all, these function prototypes I need to change. All the function prototypes are defined as per the problem statement, and print element, this print element is there. Print element will print the elements, and only difference is it will not take the number of elements into the as a parameter. It will not pass the number of elements as a parameter to the function. And in order to, since I am not allowed to enter element as a group at a time, so that is why to insert element in the array I have to use the function add element. So here I'm using add element. That means 3 elements will be inserted. So every time I want to add, I can add only 1 element at a time, and that element will be sent through add element function. Apart from that, number of elements, I am doing, I am declaring this integer as a20 as earlier, and this is defined as a global. I'm defining as a global variable. And apart from that, I am also using a variable n. This variable will tell us at any moment of time how many number of elements are there in the array A, right? Because unless I know how many number of elements are there, because there are 20 elements defined, but definitely there will not be 20 elements. So I want to print only those elements where that is been indicated by the variable n. I want to print only the existing elements. I don't want to print all the time 20 elements. That's why I'm using a variable n, and that it will keep track of number of elements. Okay, number of elements in the array. So similarly, this void add element, delete element, all the functions are defined. And let me see what we did. We did nothing, no changes are done. Only thing is n. I'm using n as earlier, array manipulation. Here you can see this is I'm using n. This is here also I have not changed anything. Only I did, instead of sending the n within the function, I am making it a global variable, and whenever elements are, say here, I'm adding an element. Every time I'm adding an element, I'm increasing the value of n. Similarly, when I delete an element, I'm I'm deducting 1 from that variable n. That means if I delete an element, one number will be removed, so that's why number of elements will be reduced by 1. If I add element, then n will be increased, because this add element, one element I am increasing, so the value of n will be increased by 1. With that restriction, the same thing I have done here: add element, add element, add element. So 6, 5 and 4 will be added. Then I will see the elements in the array. Then I will delete an element, and that deleted element will be stored in y, because delete element, I have a restriction that delete element should return the value which is been deleted. So that's why I have given the return type as integer, and that y will be returned. So that value will be returned here in the del element. What I am doing, I am taking the value x, I am reducing it, and then I am sending the value of x which is been deleted from the array to the main function. So if I execute this code, and I can see here earlier it was 6, 5 and 4, now 4 is deleted and only 6, 5, 2 elements are there, right? And I can also change the sequence. I can change the sequence, that newly added element here I have added 6, I have added 5, I have added 4. This is because sequentially it will be 6 will be added first, 5 will be added, then 4. Like this way it is doing the operation. Okay, the same. I'm making some changes in this program. What I did, instead of the name A, I'm giving the name of the array as stack. Instead of n equals to 0, n, which indicates the total number of elements in the stack or in the array A, I am telling it as this is not n, the name of the variable. Only name of the variable is in TOS, right? And this is nothing but it represents top of the stack. Okay. And then instead of add element, I am renaming this function. I am renaming this function. Everything is same, only the name is different. Add element is changed to push. Del element is changed to pop, P-O-P, right? This is changed to pop. And similarly, print stack, instead of print array in earlier program, print elements, I change it to print stack because I want to print the content of the stack, and that's why I have changed it. And rest of the things, whatever it was, there was 3 statements: add element, add element, add element. Here also I did the same thing, push, only add elements are changed to push, and rest of the things I'm printing the content, right? And same thing, if I write this program, instead of n I'm using now TOS, instead of A I am using stack. That rest of the things are same, and all restriction that is imposed on the previous program are also applicable here. If I run the program, the same thing will happen. 6, 5, 4, these 3 elements are entered and it is printing. Now again I can do one thing, I can delete an element accordingly. I can see that, and that will be reflected here that the element are deleted. Okay, now let us go one step ahead, one step more. And in that case, what I will do, I will apply the concept of abstract data type. Abstract data type, basically implementation details of certain functions are hidden or separated or segregated from the main program. That's what I will do. In order to do that, I will segmenting first this one, and also what I will do, you can see this is a program .c program, and this program has push function. This program has pop function, but we do not have any declaration in this particular program. But if is the program, this program is a very clean program. This program is a very clean program, and what I am doing, as we know that push is nothing but add element, and that element will be added to certain array, and this push, and then printing the stack, then popping the element, again printing the stack. Right, let me execute this code and let's see what happened here. Let me clear this screen. So I am executing this code, and you can see here, first of all, 654, these elements are added, and after that I am popping one element. That means one element is deleted. That's why one element deleted means this one. This is considered as top of the stack. This element is deleted, and now only remaining elements are 5 and 6. Again, if I call one more times this function, if I call one more time, then let us say yy here p, and instead of this integer no need to be defined once again. So if I write this pop another element, so it should give yy, then here I'll again print the stack, so it should give 6 because 5 will also be deleted. Let me see what happens here. So first it has deleted 4, then it has that's why 5 6 are there. After that it is deleting 5 and it remains only 6. So that way what I did, I just transfer the definition of different functions into a new file, and I'm putting all the declarations in the stack.h, right, stack.h, and in the main function I'm just calling these operations or calling these functions, and it will look like, as we do not have the implementation detail with us, but still we are able to use this function. And when we put this restriction in an array of integers, and moreover instead of defining all the things in the same program, we segregate the implementation details of the operations like push and pop, then that array is special array and considered as a stack. Main purpose of this this discussion is to understand what is a stack, right? It's nothing but an array, as we have seen, an array with some restrictions. The restrictions are, first of all, we can add only one element at a time, and we can delete only one element at a time. Addition and deletion takes place only at the top. What does this mean, only at the top? We have seen that when we declare the array of stack, this is stack, it's no longer a, now the name of this array is stack, and we have elements, and this is maximum, we can go up to 20 elements, we have seen that, right? However, every time when we add this element, we use a variable TOS. TOS initially is 0. When we add element, it will add the new element in this location, which is 0 1 2 3 4, that way, and after that it will increment the value of TOS. Next time when I will call push function, say 5 will be added here, because now the TOS is equals to 1. Once we add it, it will be incremented to 2. Then when I add this, it will be added here is 4. Then it will be incremented by 1. Now if I add one more, if I write down one more for push 7, then definitely it will be added here, right? So this is the restriction in this array, that every element, this is considered as top, this is the bottom, and if you compare, if you represent this array, pictorial representation of the array upside down, that means you can write down here, this is 0, this is 1, this is 2, that way it will go on. Just simply we are representing the array in vertical form, where the last element will be in location 0, right? And then it will go keep on adding elements 6 5 4 3, that way, and every time TOS, this TOS will be pointing here, TOS, and new element will be added here 7, new element will be added this place, because at this point at this time TO is pointing to this location, and once we add element, immediately TOS will be increased and it will point to the next higher location. So in that case, it is said that the elements are added at the top of the stack, and when we delete, we also do the then also we do the same thing. We delete the element from top, and immediately we keep this one, we keep this TOS down to represent the top element, or to point to the top element of the array. So that's why this TOS indicates that either addition, or addition also known as push, and deletion also known as pop, push and pop operations to be carried out in a location where it is pointed or denoted by the variable TOS. Okay, so that is the concept of stack. and that stack is actually ADT. Why it is ADT? Because it is abstract data type, because the implementation details of push, pop and any other functions or operation defined with respect to stack, with respect to the stack array, is normally hidden from the programmer or user of the stack. That's why it is considered as a, that is why it is considered as a abstract data type.